Next problem. A simply supported beam of span 6 meter carries UDL of intensity 40 kilonewton per meter over half of the span. A simply supported beam spans 6 meter carries UDL intensity of 40 kilonewton over half of the span. The cross section of the beam is symmetrical in I section with the following dimensions: overall depth equal to 300 mm, flange width equal to 120 mm, flange thickness 25 mm, web thickness 12 mm. See, evaluate the maximum bending stress induced in the beam. They asked to evaluate the maximum bending stress in the beam. Just you see the figure first. See, this is the 6 meters simply supported beam. From left side of the half span have 40 kilonewton per meter of UDL, that is 3 meter. The reaction at A equal to 90 kilonewton and B equal to 30 kilonewton. See the maximum bending moment I section of the beam, shear force SF diagram in kilonewton. 90 kilonewton is here and 30 kilonewton is here. So from C, the D is have X. So where shear force is 0, the bending moment will be the maximum. So the cross section of the beam is like this. So web thickness is 12, overall height is 250, D equal to 250 and width equal to 120. So web thickness, here the web thickness 25. So this is the figure about the problem. So to find the maximum bending stress induced in the beam F max, so we want to find F max in Newton mm square. Solution is, let RA RB, first we find the reactions at the supports. Taking moment about A, moment IRB into 6 equal to 40 into 3 into 3 by 2, that is equal to 180. That is equal to 180. Then RB equal to 180 divided by 6, we got 30 kilonewton meter. But RA plus RB equal to 120 kilonewton overall. So here that's why we RA have 90 kilonewton. The bending moment maximum at a point where SF equal to 0. As you know, the bending moment maximum at a point where SF equal to 0. Let D the point at a distance x from the point C, which shear force is 0. We have already seen the shear force is 0 at D. C. SF at D equal to minus 30 plus 40x. So shear force at D equal to plus summation of plus and minus values, x equal to 30 divided by 4 equal to 0.75 meter. Maximum bending moment at D equal to plus 30 into 3.75 minus 40 into 0.75 into 0.75 divided by 2. So we got the value of 101.25 into 10 power 6 Newton meter. Moment of inertia of the section about an axis passing through the centroid and parallel to the bottom face. That is I equal to BD cubed by 12 minus of again BD cubed by 12. We got the 1.294. Here the 120 into what they done, 120 into overall 250. The D is here BD cubed by 12 minus of the I section. I section is 108 into 250 cube divided by 2. Answer is 1.294 into 10 power 8 mm power 4. So moment of inertia of the section passing through the centroid and parallel to the bottom face moment of inertia is overall moment of inertia minus I section moment of inertia. So we know that m by I equal to F max divided by Y max. The F max equal to m by I equal to Y max. So put the values m equal to 101 into 10 power 6 and Y max 150 divided by 1.294 in 10 power 8. We got the answer 117.4 Newton per mm square. The result is the maximum bending stress occurring in this section equal to 117.369 Newton per mm square. A cast iron water pipe 450 bore and 25 thick is supported at two ends 9 meter apart. So pipe length is 9 meter. So inner bore 450 and the thickness is 25 Find the maximum stress in the metal. The two cases, A when subdivision A when it is running at full condition, subdivision B when it is empty. So find the maximum stress in the two cases. Specific weight of the cast iron 78 kilonewton per meter cubed and that of water is 10 kilonewton per meter cubed. So given data, first of all, inside diameter of the pipe equal D2 equal to 450 thickness T equal to 25 So length of the beam, length of the pipe equal to 9 meter 9000 Specific weight cast iron 78 kilonewton per meter cubed, that is equal to 78 into 10 power minus 6 newton per meter cubed, and specific weight of water equal to 10 kilonewton per meter cube, 10 into 10 power minus 6 newton per meter cube. Maximum bending stress F max equal to 8 newton per square. So these are all the given data. So if we want to find the maximum stress in the pipe when it is running at full condition, F max in newton per square, as well as in empty condition, F max equal to newton per square. So solution is outside of the pipe D1 equal to D2 plus T, that is outside of the pipe equal to D1 equal to D2 plus T, that is 450 plus 50 equal to 500 Cross section area of the pipe A equal to pi by 4 into, this is hollow, so pi by 4 into D1 square minus D2 square, we got the answer of 37306 square. Weight of the pipe per unit length, W1 equal to A1 into specific weight of the pipe. Weight of the pipe per unit length equal to W1 A1 into specific weight of the pipe, that is 37306 into 78 into 10 power minus 6, that is equal to 2.91 newton per So cross sectional area of the water section A2 equal to pi by 4 into D2 square. So inside the diameter of the pipe, pi by 4 into 450 square equal to, answer is 159 into 10 power 5 square. This is the cross section of the water section. Okay, weight of the water per unit length W2 equal to A2 into specific weight. So specific weight equal to 159 into 10 power 5 into 10 power minus 6 equal to 1.59 newton per So first question, when the pipe is running full, total weight per unit length equal to W equal to W1 plus W2. So the 2.91 plus 1.59 equal to 45 newton per square. In case of simply supported beam subjected to a UDL, bending moment maximum at M equal to WL square divided by 8. So put W equal to 4.5 into L equal to 9 meter divided by 8. So we got the answer of 45.563 bending moment at full running pipe. So distance of extreme layer from neutral axis, y max equal to d by 2, that is equal to 500 divided by 250 The moment of inertia I equal to pi by 64 into d1 square minus d2 square hollow pipe. So we got the answer 1.055 into 10 power 9 power 4. We know that m by I equal to f max by y max equal to f max, that is equal to f max equal to m by I equal to y max. So put the values and got 10.797 newton per square. So the case is when the pipe is running full, the bending stress equal to 10.797 newton per square. When the pipe is empty, only the pipe weight consider. Pipe is empty, pipe weight only consider. So weight per unit length W equal to W1, that is 2.91 newton per In case of simply supported beam subjected to a UDL, maximum bending moment W equal to WL square divided by 8, that is equal to 2.91 into 9000 square divided by 8, got the answer of 79.4 into 10 power 6 Newton mm. So we know m by I equal to f max by y max, f max equal to m by I y max. So put the values and got the answer of 7.33 Newton per mm square. As a result, stress in the pipe when it is running full, f max equal to 10.7 Newton per mm square, and stress in the pipe when it is empty, f max equal to 7.33 Newton per mm square. So just our conclusion is running full is more stress when compared with the empty pipe.